So next one is counter. So counter is a sequential circuit. Also the counter, it will be count the clock pulse. They have two types of counter: asynchronous and synchronous. Asynchronous also only uh, known that namely ripple counter, and synchronous counter. Okay, so asynchronous and ripple counters. So this is synchronous counter. So asynchronous counter, the clock is not directly connected to the all the flip flop. So the input connected to here, the clock is given first one, then remaining thing is the output connected to the clock for the second device. Similarly, every device clock get it from the previous device. This is a up counter. So up counter. So and for down counter and up counter, then the main difference is see that Q bar. This is Q normal output. This is inverted output. That inverted output given the clock of the device. And here that inverted part given to the input of this place, and then normal output will be given to the clock. So that's the main difference for down counter and up counter. So up counter normal inverted output given to the given the clock to the next device. Then output also given to so, that feedback loop also given that inverted output given to the input of this flip flop. Okay, for flip flop is always have the feedback path. But the only thing is the different is inverted output given the clock of the first second device. But here normal output uh, given that clock of the second device. So down counter. So this is up counter and down counter truth table. So the clock counting the clock pulse is towards to the highest value, that is up counter. With the counting the clock pulse towards to the lower value, that is down counter. Okay, the left side it is up counter truth table, and right side it is down counter truth table. And this is the up and down counters. So both are available in the one same single um, diagram. So this is up down counter. Okay, so now we are going to see about the coding part. So this is up down counter. This is a diagram. We have that up counter and down counter. So this is a basic diagram. This is up down counter diagram. So here we are used flip flop 1 and flip flop 2, flip flop 3. There are three flip flops they are used, and here up and down. So when we used the value that will be inverted value will be go there, then that is down counter. If you use the regular value, normal value, it will be go there. It is up counter. So this is a coding part. So here we are using the coding part. So entity, the port reset, flag control, then counter, so standard vector 2 down to 0. So this is the counter architecture. To begin the process, reset flag control, and begin if reset is 1, then count it started um, 0 0 0 because we are used to 3-bit counter, so it is 3 0 is there. Else if reset is 0, then if the count will be 0 0. Else if rst 0, then if control 1 and clock 1, then count plus. Okay, else if they have to if it is reset is 0, then controller is 1, clock is 1, then count. So after that it will be starting the count. If it is reset is 1, there is no count, that is counter is 0. If reset is 0, then the clock is 1 and then control is 1, then counter will be start. So you have to count plus 1. So that is a count. So else if the control is 0, then clock is 1, then control 0, then clock is 1, then count is count minus 1, because it is down counter. If controller having 1, that is up counter. If controller having 0, that is called as down counter. So end if end process and end up down counter. So this is very simple. There are reset, control and clock. If it is reset is 0, the counting will be start. if it reset is 1 and then counting is stopped, that is 0. So the reset is 0, the counting is started. So counting, when it will be counting started, control 1 and clock 1, then counting will be started, that is count plus 1. So if the controller is 0, then counting is counting will be downwards, it's a down counter, counter minus 1. So when controller is 1, counter plus 1, controller is 0, counter minus 1, so remaining the same. Okay, thank you.